And take on this one. Look at that already. 1 hour and 8 minutes gone. We'd have had 90 minutes to do 4 more questions. You see how fast time moving, Keith? All right, we have 90 minutes to do 4 questions. Of course, we are practicing, so in an exam, we'd have to be moving a little bit faster, but no worries. So now it says a sequence is defined by this recurrence relation. Un plus 1 is what? Un plus 1 is, oh, un plus 1 is un plus n. So let's write that down. So this is module 2. I'm going to write M2. And it tells us that un plus 1 is equal to un plus n. All right, that is it, un plus n. All right, nice. So this is module 2 right here. And it says, and it tells us that u1 is 3. Find the first 4 terms of this sequence, where u1 is equal to 3. I was supposed to find the first 4 terms of this sequence. So we already know the first term, u1 is 3. Now we need to find u2. To find u2, we plug n equal 1 in the formula. To get u2 is u1 plus n, where n is 1. So u2 is going to be 3 plus 1. Really? This is such an easy question. 3 plus 1, which is 4. That's u2. Then now we're going to work out u3. u3 is going to be u2 plus n, where n is 2. You see why n is 2, Marika?
Yes, sir.
So this is just 4 plus 2, which is 6. So that's the third term, 6. Then now we need u4, and u4 is going to be equal to, what's u4?
U4 would be U3
u3 plus
3.
Plus 3. Very good, Marika. Very good. So it's just 6 plus 3, and 6 plus 3 is 9. Good, good, good. Nice, Marika. Nice. So those are the first 4 terms of this sequence. So if we list it as a list, to write it as a list, it is 1. No, I'm lying. It's not 1. It is 3, 4, 6, and 9. Okay, beautiful. I shouldn't have put an, I should have put another comma. So that's the first 4 terms of the sequence. So that's part 1. Now the next thing they want you to do, so list out the first 4 terms. 3 marks for that, you know. 3 marks to write the first 4 terms. Just for write 3, 4, 6, and 9. That's so nice. Now this is why I don't like keeping a Marika. Look at this. This is 3 marks. And you're telling me this integration that we did was also 3 marks? What?
Oh yeah, the integration is 4. So the one before differentiation. Yeah, the differentiation was 4 and this is 3.
That's crazy. How is this 3? And this just to do this. This is 3, what?
I honestly, I think what they do is that they just pick random questions and say, oh, let's put that there. And they say, oh, this is too easy. Let's put a new one. And they don't care about, they don't look at the marks. They just put whatever random numbers they want.
Yeah, well, we're still unclear of how they generate their numbers, but I guess you're making a good valid point there. I'm not sure how they come up with some of these numbers, because that's crazy. But let's continue. It says, prove this by induction now. Un is n squared minus n plus 6. So we need to prove that un is equal to n squared minus n plus 6. And I think that's over 2. All right, we need to prove this. So to prove this now, Marika, Let's do it in black first. Number one, we need to see if the formula correct, of course. So remember, originally, we know say U1 supposed to be 3. So now testing the formula, U1 is equal to, plug in 1 up here, so we get 1 square, which is 1, minus 1 plus 6 over 2, and yes, that is 3. So the formula works. So therefore, n equal 1 is true. N equal 1 is true. All right. Now that the formula works for n equal 1, let's check it out now and assume say it's true. So we're going to assume that it's true. Assume true for n equal k. Assume true for n equal k. And what we're assuming true is that, this is for n equal k, we're assuming that uk is going to be equal to k squared minus k plus 6 over 2. That is what we're assuming. All right, this is what we're assuming to be true. Now, Marika, let's write down what we're required to prove. So I'm just going to write it right here in the corner over here. So we're required to prove then, we're required to prove uk plus 1. We're required to prove that uk plus 1, we're supposed to can replace n with k plus 1, and we're supposed to get k plus 1 all square minus k plus 1 minus in bracket k plus 1 plus 6 over 2. This is what we're supposed to prove, right? We can replace n with k plus 1. This is what we're supposed to get. I can put 6 over 2. So we're supposed to get this, Marika. So what we're going to do is check it out. So let's go to step 3 now. So step 3 now, this is for n equal to k plus 1. For n equal to k plus 1, Marika, what you're going to have to do is go back to the recurrence relation formula, them giveaway. This is what them did giveaway. So when n equal k plus 1, right, just replace n with k in this right here. So using that formula, we're going to get uk plus 1 is equal to uk plus n. In this case, n is k. So uk plus 1 is uk plus k. But Marika, we already assumed something about uk. We assumed that uk was equal to k squared minus k plus 6 over 2. So that's what we have plus k now. Now, Marika, this is just fractions now. So all we have to do now is put a 2 right here and divide it by a 2. So now we can add them. We just can add them now regularly. Yeah, we can add them regularly now, don't we? Right?
Yes, sir.
So now we're just gonna get k squared. So now we're gonna be k squared. Now look at what I'm gonna do, Marika. Now this might seem crazy. Instead of subtracting the k from this 2k right here, so I'm gonna put the 2k here, so instead of this 6 right here, I'm gonna break up 6 as plus 1 plus 5. Don't worry what happened. I just breaking up 6 as 1 plus 5. Then the minus k I'm gonna put on the outside right here as minus k over 2. Is that cool so far, Marika?
Yes, sir.
Now, Marika, look at this. Remember, k squared plus 2k plus 1, that is k plus 1 all squared, huh? That part there, k plus 1 all squared, right? If you're to expand k plus 1 all squared, you would get k squared plus 2k plus 1, don't you? Right?
Yes, sir.
So I can actually replace this with k plus 1 all squared. So now I can just tell them now, say, uk plus 1 is now equal to this part right here, is k plus 1 all square. This is now k plus 1 all square minus k plus 5 over 2. Now, Marika, the thing is, I need a negative 1 right here. So look what we're going to do. This is why I tell you it's a lot of gymnastics. But look at this now, Marika. I need a negative 1 right here. So what I'm going to then do is, let me just put a slash off. We're going to end up getting now uk plus 1 is to generate the negative 1 that we want, Marika. We're just going to put it there because we're bad like that. Yes, we're bad like that. We're going to put it there, but then we're going to subtract it. We're going to add it back. We're going to have a minus k here. We need a negative 1. So I'm just going to subtract back 1. I'm going to subtract 1, but then I'm going to add back 1. Does that make sense? If I add back 1 from subtracting 1, I didn't trouble the question though.
Yes, sir.
All right, and then we'll put plus 5 over 2. Now, after doing that, Marika, you see that 1 under 5 here, this turn to 6, no? Right?
Mm-hmm.
Yeah, so what we get now is uk plus 1 is equal to, this part becomes now k plus 1 all square. Now, follow now, Marika, you see this right here, so? This minus k minus 1, I can factor out a negative 1 to get minus in bracket k plus 1. And then the 1 plus the 5 is 6 over 2. So we get all supposed to get. See, that we're done. We get all supposed to get. See there? Get all supposed to get. So finish. So now we're right. Therefore, n equal k plus 1 is true. So a little bit of gymnastics, right? Therefore, n equal k plus 1 is true. Then, of course, Marika, you know, step 4, I always write it. Step 4 is write your conclusion. Write your conclusion. You can write, therefore, by principles of mathematical induction, the mathematical statement that tells us that un is equal to n squared minus n plus 6 over 2 is true. This is true. All right, it is true. Cool it, this, Marika? It's true. Oh, nice.
Yes, sir.
Nice. So finish off that part.
I need to practice more with the k plus 1 thing.
Yes,
and
I realize.
put it as true. I can't. I realize. I can't. Like, I'm always thinking it's gonna be easy, and then I reach to a point like, how am I going to get it to look like this?
I realize it. I realize you're good with the divisibility. I have that part put down, but the summation and the sequence one is where you're having difficulties.
Yes.
All right, so you just need to practice some more. All right, you need to write down what you're trying to prove and then think of how you're going to get there. It's not always going to be the same. All right. So do this, now do this. Now say an easy question here now. It says a GP with first term A and common ratio. Let me just copy this question. All right, help me to copy slowly. Yes. All right, so now I copy this question. You can put it right here. It says, what? Why does it come out like this? Oh, I saw what happened because of the typo, or how it was typed. So I can't copy it like that. It says a GP though with a first term A and a common ratio R as sum to infinity 81. So if it has sum to infinity 81, Marika, they tell you that the sum to infinity, we know sum to infinity formula is A over 1 minus R, and then tell you say the sum to infinity is 81. So just writing down the information that they give you, it already looked like a simultaneous equation. See it here? We write down this sum to infinity, 81. And it says the sum of the first 4 terms is 65. Them said the sum of the first 4 terms. So the sum of the first 4 terms, Marika, is 65. So the first term we know is A for any geometric progression. The second term is A times R. The third term is A times R square. And the fourth term is A times R cube. And this is equal to 65, right?
Yes, sir.
So now we just need to solve this simultaneously. Imagine that this will
Oh,
come
so
to...
just one question. How did you get the 65? Is that another part of the question?
Oh yes, let me show you. They said right here that the sum of the first 4 term is 65.
Okay.
All
Some of
right.
it. Okay, understand.
Yeah, so that's why we add here the first term, the second term, the third term, and the fourth term. We'll add them, we'll get 65. All right, so that is why we have that. So these are our 2 equations that we have now. Sum to infinity is 81. Sum of the first 4 terms is 65. Let's do the simultaneous equation. Now from the second equation, Marika, I can just... All right, I didn't want to do it that way, but from the first equation, I'm going to make A the subject by cross multiplying, and I end up get A is equal to, cross multiply, A is 81 minus 81 times R. You get this for the same? I make A the subject by cross multiplying, you see it?
Yes, sir.
All right, so this is A. A is 81 minus 81R. Now, I don't want to substitute it for A because then this is going to be a long expression. R to the, all right, we're going to have to do it anyway. To substitute it, we're going to get 81. Try and see if there's a shortcut. Factor out A and I have 1 plus R squared plus R cubed. All right, no, I don't see the shortcut. So I'm just going to have to put it there. This is 81 minus 81R plus A times R now, Marika, is going to be 81 minus 81R. And this is multiplying by R. Then I have plus the same thing again, 81 minus 81R. And this is being multiplied by R squared this time now. Let me write the R better here, so 81R. And then finally we have plus A, which is 81 minus 81R. And that's being multiplied by R cubed, and this equals 65. Now you might say this look tough, like it'll take forever. No, it won't. So look at this now. We're just going to expand now, Marika. We're going to get 81 minus, this is 81 R. Then this becomes plus another 81 times R. That's now, oh, I see what happened. It all work out nice. Look at this, Marika. 81 times the R, I'm going to give it 81R. Do you see what happened already? This minus 81R and this plus 81R cancel down.
Yes, sir.
Them actually make it work out easy, because like this would have been crazy to work out. And this times this now give me minus 81 R squared. But then now on the next side, 81 times R squared, that give me plus 81 R squared. See, cancel again.
Oh,
No,
so
this part cancel this part. So now we just need to multiply 81 times minus 81 times R squared. That's going to give me minus 81 R cubed. And I bet it's going to cancel again. Then 81 times R cubed, that's plus 81 R cubed. It cancel again, no? Yeah, see there? This cancel again. 81 R cubed. 81 R cubed cancel with this, then they cancel. Then finally, minus 81 R times R cubed is minus 81 R to the 4. And that equals 65. So notice all of them, they cancel. Marika will underline. So this equation does reduce simple to be 81 minus 81 times r to the 4 equals 65. It works out simple, though. Right?
Yes, sir.
So
I
can
guess
bring up.
they did it in the way so you can just cancel them.
Yeah. Looking at it would have been, why they give it this? But then we realize it's not too bad. Now, Marika, really rusty, meaning I feel a little bit tired. So I'm going to have to pop out the calculator and work out 65 minus 81. That's embarrassing, but just a little weary today. So,
Sir, I do that.
all right.
Sometimes I look at I can do it, but
Yes.
then I just don't trust myself.
Too much energy. Oh, okay. Oh, it's not a matter of trust. It's just sometimes it's just, you feel a little tired. So don't, but just use a calculator. Just use it.
Sir, I still count on my fingers, sometimes I do that.
Yeah, I understand. All right. So now we just divide out by negative 81. So what we're going to get is r to the 4 is equal to 16 over 81. That's r to the 4, 16 over 81. So to find r, we just need to square root it twice. So find the quart root. So r is the quart root of 16 over 81. Look, I'm going to do this without the calculator. The quart root of 16 is 2. The quart root of 81 is 3. That much I know. R is 2 over 3. Now let's verify if I'm telling you rubbish. I know the quart root of 16, that is right. So let's check it out. The quart root, forget quart root. It's this one, yeah, quart root of 16 over 81. See it there, 2 over 3, man. Yeah, that's R, 2 over 3. So this is 2 over 3. Nice. So now that we get R, Marika, now we can find A. So we can sub in back in here now to remember that A over 1 minus R, which is 1 minus 2 over 3, is 81. Subbing in the first equation. So then 1 minus 2 over 3 is 1 over 3. So we get A over 1 over 3 is 81. But anything divided by a fraction, you can just flip it to get 3A is 81. And so A equal 27. A equal 27. That's it. That's the first term. So we can tell them A equal 27 and R equal 2 over 3. This wasn't too bad, right?
No, sir, it wasn't.
Nice. So we can tell them right there that in this case, A equal 27, R equal 2 over 3. Nice. All right, now the next one we want to work out, it says write down the first 5 terms in the power series expansion of ln 1 plus x. Write down the first 5 terms in the power series expansion of ln 1 plus x. And it says state the range of values of x for which this is valid. The first 5 terms. Now, Marie, come and tell us that them people are wicked, We're going to use Taylor-Maclaurin series. We're going to write out 5 terms. We're going to differentiate 5 times. And you give it 3 marks? That's crazy. Okay. You see what I'm telling you? They're not distributing the marks correctly. This cannot be. This is ln 1 plus x, and you only want to give us that meager skinny marks, ln 1 plus x. Come on now. So we're gonna call this f. All right. Let's just write down back Maclaurin formula. So remember Maclaurin formula, Marika, it tells us that f of x, you have to remember it, is equal to f of 0, it's f of 0 plus f prime of 0 multiplied by x, then it is plus f double prime of 0 multiplied by x squared, and this is being divided by 2 factorial. Then we have plus f triple prime of 0 x cubed over 3 factorial, and it continue. Now, Marika, do you think differentiating so much time we should only get 3 marks? Just be honest. Do you think this was worth 3 marks?
I think it should be worth higher.
At least, very good. That's the same that I said 5. But that's what they say. So first, let's find f of 0. To find f of 0, we'll plug in 0 in here. And so it's going to be ln 1 plus 0, which is ln 1. ln 1 is 0. So that's f of 0. Now we need to find f prime. To find f prime now, we differentiate ln 1 plus x. When we differentiate ln 1 plus x, we get 1 over 1 plus x. And so that means f prime of 0, if we plug in this now, plug in 0 in here, that become 1. F prime of 0 is 1. Now we need f double prime. Before we can find f double prime, let's rewrite this as 1 plus x to the minus 1, so it's easy to differentiate. We need it to be easy to differentiate all the time. So now f double prime is going to be carried down the power. That's minus 1. Subtract 1 from the power, which is now 1 plus x to the minus 2. I will multiply it by 1. Timesing it by 1 won't do anything. So now we can find f double prime of 0, and plugging that in, we're going to get minus 1 times 1 is minus 1. Now we need f triple prime. 1, 2, 3, f triple prime of 0. That's going to be equal to, plug in 0, differentiating 5 times for 3 marks, and oh my God. But I said the first 5 terms, 1, 2, 3, 4. Oh God. So now we carry down the power. We get 2, minus 2 times minus 1 is 2. So that's now 1 plus x to the minus 3. So that means that f triple prime of 0, is positive 2. Ooh. Now we're going to go again. F prime is equal to, carry down the power, we get minus 6 times 1 plus x to the minus 4. My God, they are cruel. And so now, what we get is f prime of 0 is equal to, replace this with 0, we get negative 6. Now, Marika, we're almost done. One last differentiation left now. So now one last differentiation, we get now that f prime will be equal to, carry down the power, that's 24. Subtract 1 from the power, which is 1 plus x to the minus 5. So that means f prime of 0, or plug in 0, 1 plus 0 is 1, 1 to the minus 5 is 1, 1 times 24 is 24. So Marika, following Maclaurin's formula, let's write it around here, and then wicked, so this is 3 marks. F of x is equal to f of 0, which is 0. Then we have plus f prime of 0. F prime of 0 is 1, so we have 1 times x. So it's now plus 1 times x plus f double prime of 0 times x squared. F double prime is right here. This is minus 1. So this is now minus 1 times x squared over 2 factorial, which is 2. Then we'll go back around here now, Marika. F triple prime. of 0 is minus 6. So this part here is minus 6x cubed. Wait, where's f double prime? So f triple prime here, I make a mistake. F triple prime is this 2. F triple prime is 2. This is going to be plus 2x cubed over 6. That's 3 factorial. Then I realized that it's a plus. This was actually minus 6. So let me change this to a minus. Minus 6 times x to the 4 over 4 factorial, which is 24. Then I have minus 24 times x to the 5 over 5 factorial, and 5 factorial is 120. So this is f of x, Marika. In other words, we're saying that ln 1 plus x, this can't be 3 marks, but they say ln 1 plus x is equal to x minus, this is x squared over 2. Now instead of 2 over 6 there, we can write that as 1 over 3 to say it is x cubed over, no, x cubed over 3. 6 over 24 is 1 over 4. So that's minus x to the 4 over 24. And then this would be now 24 over 120 is minus, 6 over 24 is 1 over 4. And then 24 over 120 is x to the 5th over 5. This is it, Marika. I promise you this should have been 5 marks. I promise you, they're cruel. They are. Then them tell people about the time done, 2 hours and 30 minutes, when this should have been a 3-hour exam.
I always thought that too, you know. They should have made it longer.
Yeah, it should have been a 3-hour exam. I still can't understand why it's not a 3-hour exam. I think a lot of exams that get 2.5 hours are way easier than pure math. I'm just being honest. And I think pure math deserves more time if other subjects get 2.5 hours. All right, so that is that. That's ln 1 plus x. So it also said tell where x is, them even add on this on it too, you know, for 3 marks, state where x is valid. My gosh. Oh boy, this alone should be 1 mark out of the 3. So that's crazy. So now to tell them where x is valid, Marika, we cannot find the log of a negative number. Since we cannot find the log of a negative number, it is valid when x is greater than or equal to, let me say 0, 0. Yeah, when x is greater than or equal to 0. If x is 0, we can find ln 1 plus x. So it have to be greater than or equal to 0 for to be valid. Well, actually, it have to just be strictly greater than 0. Let's just write x is greater than 0 to be valid. Nothing wrong if we put greater than or equal to, but in a case where you're going to approximate something, they wouldn't ask you to approximate 0. So this is where it's valid. This alone should be 1 mark. You can't tell me the rest of that word 2 marks. So that's crazy. So this is definitely not 3 marks, but that's it. Now let's hear what they say next. They now say using your result in part 1, obtain a similar expansion for ln 1 minus x. All right, so what they're saying is, Marika, don't expand it over. Just find an expansion for ln 1 minus x. So that's okay to give 2 marks. ln 1 minus x, then, Marika, is going to be equal to, what we're going to do is, if we did replace plus with minus, if you replace the plus then with minus, Marika, what you're going to realize is that you're always going to have to multiply by the derivative of minus 1, because you'd have to end up multiply, when you differentiate it, you'd have to multiply by minus 1, multiply by minus 1, multiply by minus 1, don't it? If it was a minus 1 in here, everything that for times by minus 1, though. Do you get what I'm saying, Marika?
Yes, sir.
All right. What we're saying is, so differentiate ln 1 plus x, you just get 1 over 1 plus x. But if it was a minus here, you'd have to multiply it by a minus 1. So in reality, round here, so you'd end up get, instead of a x there, so this would have been a minus x. Yeah. Let me see now, if this was now 1 minus that, so what we're doing is just scheming through. If this was 1 minus x, and we differentiated this, if we differentiated it with 1 minus x, let me do it from scratch. If all of these was 1 minus x, we're just going to change all of them to 1 minus x and differentiate them right here. If this was 1 minus x, we'd end up get 1 over 1 minus x. Then we multiply it by minus 1. So we'd end up get, plug in the 0, you'd get minus 1 here. Then you'd carry down the power, minus 1, subtract 1 from the power, then you'd have to times it by another minus 1. But then the minus and the minus 1 would have made this one become plus. So this would have end up become plus. So we'd end up get the second derivative being plus. So then this would have been around here. Instead of a minus here, this would have been plus x squared over 2. Let's continue now. Then differentiating that now, this would have been plus. So now minus and the minus make it be plus. So then now within the third derivative, we'd have carried on the power, would have been now been a minus 2. Carried on the power would have been a minus 2, subtract 1 from the power times minus 1. Minus 2 times minus 1 would have been, is that so? Positive 2, that don't look right. Let's check it again. Just want to make sure I don't make any mistake. Carried on the power minus 1 times a minus 1. That's fine. Carried on the minus 2. Then minus 3 times it by minus 1. Would have been positive 2. That's fine. All right. Then the next one now is carried on the minus 3. Carried on the minus 3. That make it minus 6, but then we times it by minus 1. And that have made it positive 6. What? Why is it so much positive? This would have been positive. I'm just writing. Let's just write it. This would have been positive x cubed over 3. This would have also been positive x4 over 4. Just writing down what I'd get. And then finally the fifth one, differentiating. So this would have been, as I say, carry on this, minus 3 times this. Wait, we were here. We said this would have been positive. Carry on the minus 2 times the minus 1, positive. Then now, since this is positive, it will have been a positive minus 2 here. Then bring down the minus 3. Minus 3 times positive 2 is minus 6 times this is minus 1. Good. This would have been a minus 6 for sure. All right. So the fourth derivative is minus. The fourth derivative is minus. Is this minus? It's so easy to lose concentration. It's so easy. Because this is no, just all it is change it from plus to minus. And you can see, oh, times in by a minus 1 make a big difference. At least for me. All right. So maybe you're not flustered. I'm a little flustered when I make changes like that. So bring down this. It would have been a positive 2 right here. Bring down the minus 3. Bring down the minus 3. Bring down the minus 3 upon the positive 2 is minus 6. Times it by minus 1 would have made it positive 6 now for 1 minus x. Since it is positive 6, it should have been a plus here. Continuing, it's a positive 6 right here. So bring down the minus 4 and a positive 6 made it minus 24. But then you times it back by the minus 1. That would have still made it positive 24. This would have still been plus x to the 5th over 5. All right, so that's what this would have been. We'll call it this, Marika.
Yes, sir.
All right, so it's just a whole heap of concentration. It's nothing hard. All right, and then finally, let's see what they want. They say, hence, prove that ln 1 plus x over 1 minus x is this. So ln 1 plus x over ln 1 minus x. So first thing, Marika, we're going to have to use the rules of logarithm. We know that ln 1 plus x over 1 minus x. We know that the log of a over b is equal to the log of a minus the log of b, don't it? That's the log of a minus the log of b, right? Right, Marika?
Yes, sir.
Yeah, man. So this is going to end up work out to be the log of a. We have it down around here as all of this. So write down all of that. X minus x squared over 2 plus x cubed over 3 minus x to the 4 over 4 plus x to the 5 over 5. That's what we have. This is ln 1 plus x, all of that. See it there, just to make sure. Yeah? See it there? Plus, minus, minus, minus. Oh, if I have two minus here and minus here. All right, and then it is now put the minus now, ln 1 minus x. That is now minus and then everything else plus. Minus and then everything else plus. So it's going to be minus x squared over 2. This is then minus x cubed over 3 minus x to the 4 over 4, then minus x to the 5th over 5. So this is what we're simplifying now. So now let's work this out now. As we can see right here, x minus x will become 2x. You see that, Marika? X minus x from 2x? Right?
Yes, sir.
So that part become 2x. Now, let me see, that's the x part. Now, minus x squared over 2, minus and this minus, Marika, make it become plus. So if you have minus x squared over 2 plus x squared over 2, that becomes 0, don't? Right?
Yes, sir.
And then we have minus x cubed over 3. But this plus right here going to make it become plus 2x cubed over 3, right? See that?
Yes, sir.
Then now the x to the 4, you have x to the 4 minus that cancel out each other again. And then now minus x to the 5th minus x to the 5th. Wait, this shouldn't have been a minus. This was a plus. Why did this one have minus? This should have been a plus. I have to fix this. Plus right here. This one was a plus right here. So then minus and minus become plus. So this become plus 2 times x to the 5th over 5. So Marika, as we can see now, ln 1 plus x over 1 minus x, we can factor out a 2 and see that it's working out to be x 2 times x plus x cubed over 3 plus x to the 5th over 5. Yeah, change that from 3. This should have been 3 here. Plus, and it continue. It would have been x to the 7 over 7, and it continue. And this is ln 1 plus x over 1 minus x. Cool with this?
Yes, sir.
This never too bad. I just think it deserved more marks. All right, I really think this deserved more marks. All right, so that's that. All right, nice, easy, soft. That's that. So did the proof. That's what they wanted. That's it. We only finished 3 questions so far. We have 3 more to go. All right, I will take 1 hour and 40 minutes. That's crazy. Whoa. But don't worry, the next 3 are got easy. Hopefully. All right, so now we reach question 4. Now let me just plug in my PC. All right. All right, so I plug in my PC. We're all set. All right, now Marika, question 4, we're going to tackle this, but before we tackle it, I'm just going to clear the entire white screen because I have no more pages. So to do the next 3 questions, imagine that 3 questions take all of the page then. So I'm going to clear everything. I'm going to clear all my drawings. But that should have cleared everything. Why don't clear everything? It doesn't clear everything. That's crazy. How are you finding how are you finding these key papers so far?
I think unit 1 is not too bad for me.
Yeah.
But unit 2, I need to focus on integration, and then for the sequence and series, the sequence and the series part,
All right.
I can do the divisions. And then for 3, module 3, probably probability.
Don't worry. Probability.
Because for probability, I'm not very good at reading. So when questions, I have to look at it and then like, okay, try to figure this out.
Yeah.
To get the answers from the reading, that's not one of my strong points.
Okay. All right, no problem. So we're going to tackle a lot so that you see how to develop the mindset of tackling it. So don't worry.
Yeah, because I've been practicing and I like that. Thanks, sir, for uploading more. So I was planning to get you some more.
All right. So this says now, show that the function has a root on this interval x cubed minus 3x plus 1, and then say the root alpha is on 1, 2. So this is IMVT. I know this one is very easy. So f of x equal to x cubed minus 3x plus 1. Was that 3x squared or 3x? Minus 3x, good. I'll need to show that this have a root on the interval 1, 2. So first thing we need to do is find f of 1. F of 1 is going to be 1 minus 3 times 1, which is 3, plus 1. That's 2 minus 3, which is negative 1, which is less than 0. Nice. Then now we need to find f of 2. So now f of 2 is equal to 2 cubed, which is 8, minus 3 times 2, which is 6. 8 minus 2 is 6, plus 1, 2 plus 1 is 3, which is greater than 0. So since one of them is less than 0 and one is greater than 0, if I were to give a sketch, Marika, this is how it looks. When x equal 1, the y value is -1, probably somewhere right here. This is -1. And when x equal 2, let's say this is 2. When x equal 2, the y value is 3. So that means, see it there? It looks something like this. The curve goes something like this. So clearly it have a root between 1 and 2, don't, right? Root meaning it have somewhere where it cut the x-axis. Yeah? So by INVT, there is a root on the interval 0, 1. By INVT, there is a root on the closed interval 1, 0, not 0, 1. 1, 0, 1, 2. Why I keep saying the wrong thing? 1, 2. All right, so that's that. Nice. Okay, next part now. The next thing they say now is use the Newton-Raphson method to show that if x1 is the first approximation in the interval, then the second approximation is this. So use Newton-Raphson formula. So to use Newton-Raphson formula, Marika, this is NR formula. NR formula, remember R1 is, x1 is alpha. So your approximated root xn plus 1 is equal to xn minus f of xn over f prime of xn. You have to remember this formula. This is Newton-Raphson formula. You have to remember it, all right? All right, Marika?
Yes, sir.
Have to remember this. So no worries, we already have f of x. So let's find f prime of x. F prime of x, when we differentiate, will be equal to differentiate x cubed to get 3x squared minus 3. So Marika, in that case now we can say when n equal 1 now, when n equal 1, write it down, when n equal 1, when n equal 1, Marika, that will tell us that x2 is equal to x1, but remember we're calling x1 alpha. We're calling x1 alpha, so that will become alpha. Just say wonder where we're getting alpha from. Then tell we say the first root x1. Oh, no. We can write x1. They didn't call it alpha. It's the second root is alpha. My apologies, I'm not reading right. So x2 is, write down our x1 then. x2 is x1 minus f of x, which is, just replace x cubed with x1. This is going to be x1 cubed minus 3 times x1 plus 1. And this is being divided by the way, put a bracket to show all of this is being subtracted, divided by, this is now f prime, so it's 3x1 squared minus 3. Now all you have to do, Marika, is write it as one fraction. So x2 is then going to be alpha is equal to, writing it as one fraction, this is really over 1. So if you find the LCM would still be 3x1 squared minus 3. 1 into this, leave all of this, so we'd end up with 3x1 squared minus 3 being multiplied by x1. Then we have minus all of this now. But now minus all of this, Marika, minus x1 cube is just minus x1 cube. Then minus 3x1, that become plus 3x1. And then minus plus 1 is just become minus 1. So So now we can simplify this. Now 3x1 squared times x1, that end up telling us that alpha is equal to 3x1 cube, because I multiplied the x1 square times the x1, then minus 3 times x1 work out to be minus 3, work out to be minus 3 x1. Then I have minus x1 cube, minus x1 cube. Then going around here, I have plus 3x1 plus 3x1. And then right around here, I have minus 1. And this is all over. This is 3x1 squared minus 3. No worries, Marika, we're almost finished. Now look at this. You see the 3, you see the 3 minus 3x1 right here, and the plus 3x1 here, those cancel each other. So what we end up getting now is that alpha is equal to 3x1 cubed minus x1 cubed is now 3 minus 1 is 2. So alpha is 2x1 cube minus 1 over 3x1 square, 3x1 square. Now let me write that a little bit better. 3x1 square minus 3. Pull it this, pull it the proof.
Yes, sir.
Nice. It's just one little formula we need to remember. Then it go back to prep school. It literally go back to prep school in a fraction. Nice. Now, Marika, it says use the binomial theorem or Maclaurin theorem. No, I'm not going to use Maclaurin theorem. All right. I'm going to use binomial because we already use Maclaurin. So let's use binomial just to practice how we would do it with binomial. Use binomial or Maclaurin theorem to expand 1 plus x to the minus half in ascending powers of x as far as in the x cubed term, stating the values of x for which it is valid. Then do a similar one for 1 minus x to the half. All right, so we're going to use binomial theorem. Why? The last time we used Maclaurin around here, so I don't want us to be using too much of the same. We use Maclaurin down here. We use Maclaurin here, so for the power series. So I don't want us to do another power series. All right. So just to say we use a different formula. So let's do this now. All right. All right. So now we have 1 plus x to the minus half. Let's go. Just to write down binomial theorem. Remember binomial theorem? Binomial theorem is 1 plus x to the n. And 1 plus x to the n, Marika, remember, is 1 plus n times x plus n times n minus 1 x squared over 2 plus n times n minus 1 times n minus 2 x cubed over 3 factorial, and 3 factorial is 6, right? Right, Marika?
Yes, sir.
Okay, can you hear me?
Yes, sir.
All right, can you give me a second?
Okay.
Give me 1 second. All right, are you hearing me, Marika?
Yes, sir.
All right, let's run through this one now. So 1 plus x to the n. All right, so in this case, we're going to let n equal to a half. If we stay so, boom, and let n equal to a half, 1 plus x to a half would be equal to 1 plus, replace n with a half, that's now a half x, plus, replace this n with a half, you have half times n minus 1 is half minus 1. Half minus 1 is minus half. This is being multiplied by x squared. And then we divide that by 2 factorial. So divide it by 2. Plus, n right here again now is a half again. So we have a half being multiplied by n minus 1. Half minus 1 is minus half again. Multiplied by n minus 2. That is now minus 3 over 2. This is now x cubed. Yes, divided by 3 factorial, which is 6. Yes. So now, Marika, this is just easy math to simplify. This is going to be 1 plus x over 2. Now, 1 times minus 1 is minus 1. 2 times 2 is 4 times 2 is 8. So that's minus x squared over 8. Yeah, man. And then the part here now we have minus 1 times minus 3 is 3. Then 2 times 2 is 4. 4 times 2 is 8. 8 times 6 is 48. So that is then plus 3x cubed over 48. All right, so that's just basic calculation. But if you want, 3 over 48 is 1 over 16. Yeah, this would be 1x cubed over 16. So this is the expansion of 1 plus x to the half. Pull it that, Marika?
Yes, sir.
Now they wanted expansion for, similarly, they wanted expansion for 1 plus x to the minus half. So now, Marika, all we're going to do is replace x with minus x and n with minus half. So that's what we're going to do. So 1 plus x to the minus half is then going to be equal to, replace n with minus half, x with minus x is going to be, let's use a different color, let's use black. This is going to be 1 plus n, which is minus a half, times x, which is minus x in this case, minus x, close that, plus, this is going to be n times n minus 1, so now it's minus a half, times, this is now minus 3 over 2. Then we multiply that by, in this now is minus x squared. And this is being divided by 3 factorial of 6. This is now plus, this is then minus a half, then minus 3 over 2, then minus 5 over 2, then this is being multiplied by minus x cubed, and this is being divided by 3 factorial, which is 6. So over here, so it should have been 2 factorial. I'm trying to go too fast, but 2 factorial. So now we need to simplify this, Marika. So now, simplifying, we have 1 minus x raised to the minus half. This is now going to be equal to, going back around here, this is now, this minus x cancel this work out to be 1 plus x over 2. We reach prep school maths again, Marika, it's just calculations, easy, 1 plus x over 2. This becomes minus and minus and minus square, that become positive. 2 times 2 times 2 is 8, so that is 3x squared over 8. This is now 3x squared over 8. Then around here now we have minus and minus and minus become plus. Because we have 4 minus, that's 15 over 48 plus 15x cubed over 48. We're nice, Marika, we're done. All right, well, we're not done the paper, but you know what I mean, we're done. All right, we're done. Nice. That's what we have. So this is this part right here. We'll do part I and part I. Part 3 now, Marika, it says, prove that if x is so small that x cubed and higher powers can be neglected, then the formula work out to be that. Prove that if x is so small. Now, Marika, they want us to find an expression for the square root of, let me see what this is, 1 minus x over 1 plus x. Now, the square root of 1 minus x oh, no, Marika, no. Guess what I did wrong, Marika? Can you see what I did wrong?
Can you go back, sir?
Look what I did. My sweet Lord. This around here, they wanted 1 plus x to the minus half.
Oh,
And I did this one as positive half.
so
And
that
down
means you have to
here,
start over and put them.
we don't have to do it over. It's not going to be long. This one should have been positive half. It's not going to be long. Let's just put in the minus then. It should have been minus here. It should have been a minus here. So then this would have been minus 3 over 2 here. This should have been a minus here. So this would have been a minus 3 over 2 here. This would have been a minus 5 over 2 here. And so this would have worked out to be minus x over 2 here. See, they're not that bad. And this would have worked out to be minus and minus is plus. This is now 3 over 8. So this would have been plus 3x squared over 8. And this would have been minus and minus and minus. Now this is clearly minus. This would have then been minus. And it would have been minus 15 over 48. Yeah. Then down here it should have been positive a half and not minus a half. So then we take out the minus here, that would have just been half. Take out the minus here, this should have just then been half. Then this would have been minus half here. Then we can take out the minus here. See, they now work out bad. Take out the minus here, half. This would have been minus half. Then this would have been minus 3 over 2. So it's not that bad, Marika. It'll take long to fix. All right. That's what we'd have. So expanding it out, it'll be minus x over 2 there. This would have been minus x over 2. Going around here, this would have been minus, this look like x squared over 8. It would have been minus x squared over 8. Yeah, now I'll take on a whole heap of time, man. And this now would have been minus cube times minus is minus again. This would have been minus 3x squared over 48, which have been minus 3x squared over 48. Minus 3x squared over 48, which would have been minus 1 over 16. So it never that bad, Marika. It didn't take us long. Minus x cubed over 16. It fixed now. Now we need the square root of 1 minus x over 1 plus x. We can take off the minus off of this. Yeah. So now, Marika, why them ask us this after we do all of that is because this now, Marika, is literally the square root of 1 minus x over the square root of 1 plus x. But guess what, Marika? This can be written as 1 minus x to the half. But look up there, so. See 1 minus x to the half there. We have an expression for it times that part down here, so can be written as 1 plus x to the minus half. But we also have an expression for this. right? We also have an expression for this. So since we have an expression for this and we have an expression for this, we're nice. So now Marika, we're just gonna multiply them here across. All right, so now we're gonna multiply this across. So 1 minus x to the half, this is 1 minus x over 2. This is 1 minus x over 2 minus x squared over 8 minus x cubed over 16. And all of this is now being multiplied by, around here now, 1 plus x to the minus half. The expression we have for it is right here, which is 1 minus x over 2, 1 minus x over 2, around here, that is plus 3x squared over 8, and then this is minus 15 over 48x cubed. All right, so now we're just going to multiply them and simplify it. So now to multiply it and simplify it, we're going back to grade 10 maths, right? That's basic maths. We're going to multiply out 1 times all of this. 1 times all of this will give us 1 minus x over 2 plus 3x squared over 8. Then we have minus 15x cubed over 48. Yeah. And then now, Marika, what we're going to do is multiply the minus x over 2 times all of this. Minus x over 2 times 1, that's going to be minus x over 2. Minus x over 2 times minus x over 2, that is plus x squared over 4. Then minus x over 2 times plus 3x squared over 8, that is minus 3x cubed over 16. Now, Marika, we can stop right here. So we don't need to multiply the x times the x cubed because that will give us x to the 4. We don't need x to the 4. Then we can multiply x squared over 8 times 1 to have minus x squared over 8. Then we can multiply minus x squared over 8 times minus x over 2 to get minus x cubed over 2 times 8 is 16. Then we can multiply minus, and we're done there, so then we'll just multiply minus x cubed over 16 times 1 to get minus x cubed over 16. Cool it this, Marika?
Yes, sir.
All right, now let's simplify all of this that we have right here. We need to simplify all of this. Now, Marika, look on this. Look at this, look at this. Look how nice. Minus x cubed over 16, minus x cubed over 16, minus 3x cubed over 16. Wait, something look off. There should be a plus here or something, so they cancel. Let me see what happened, because this is minus. All of these is minus, and they should have canceled. They should have. Did we expand correctly? Yeah. All the signs are correct. Minus, plus, minus. So we expanded right up to there. Minus, then plus. This would have been x minus x squared over 8 times x over 2 minus, and minus, this should have been plus. All right, see it here, minus x squared over 8 times minus x over 2. So these two cancel. All right, these two cancel. Good. So we end up get our expression being equal to 1. Let's simplify our x terms now. Minus x over 2, Marika, minus x over 2. That's just minus x, right? If you have minus half and minus half, that's just minus 1, right?
Yes, sir.
Right? Yeah, so that does, the x part does work out to be minus 1. Good. So now let's look at our x square terms. We have x squared over 4, and we have minus x squared over 8. Only two x squared terms. So we have x squared over 4 minus x squared over 8. For these two terms right here, what I'm seeing is a quarter minus 1 over 8. That's minus 1 over 8. That's giving me minus x squared over 8. That's what I'm getting. All right, and then my x cubed terms should have been eliminated. Oh, I missed out this 3x squared. 3x squared here, so 3 over 8. I'm going to put it in the calculator. It's sad, but I have to use the calculator. 3 over 4, just to not make any mistake, minus, we had 3 over 4, 3 over 8, sorry, plus over 1 over 4, minus over 1 over 8. Just to be safe, that's a half. All right, that's a half. That is a half, Marika. All right, so this should have been a half. You see the half? This should have been a half, right? You saw the half, right?
Yes, sir.
So the half is x squared over 2. That's what's a half. All right. Then now we have plus our x cubed term. But Marika, guess what? The question said we can neglect our x cubed term. We can neglect it, so we don't even need to put no x cubed, nothing. Just put plus dot, dot, dot. It's done. So the question done. This is the answer. Remember, it said we can neglect our x cubed term. So 1 minus x over 1 plus x all square rooted is this. So remember, we neglect x cubed terms since x is very small. So we don't need to worry about the x cubed term here. Right, Marika?
Yes, sir.
Because that's what they said. They said neglect your x cubed term. See there? X is so small that x cubed and higher powers can be neglected, meaning take them as 0. Yeah? All right. Now it says, Marika, hence by taking x as 1 over 60, 1 over 17, show that without using a calculator, root 2 is 1635 over 1156. So all we're going to do is substitute x as 1 over 17, right? All right, Marika? Can you hear
Yes,
me?
sir.
Good. All right, so let x equal 1 over 17. So plug that in now. Our left-hand side is going to end up being now x is 1 over 17. We get 1 minus 1 over 17 over 1 plus 1 over 17, all square rooted. This we have right here. This is then going to be equal to, plug in this as 1 over 17, we get 1 minus 1 over 17 plus 1 over 17 square, 1 over 17 square over 2. Now, Marika, we're not going to use the calculator. We're testing our brain capacity. Let us do so now. 1 is 17 over 17. 17 minus 1 is 16. So this is just 16 over 17. And this is being divided by 1 plus 1 over 17, which is 18 over 17. Right? Cool with this?
Yes,
Right,
sir.
Marika? All right. All right. That's that. Nice. And Let's expand out this side now. We have 1 minus 1 over 17. And then 1 over 17 square. 17 square is 289. And 2 times 289 is 588. So that is just plus 1 over 588. Sharp, don't it, Marika? No calculator, don't it? We sharp, don't? Right?
Yes, sir.
Nice. So now the root of 16 over 17 over 18 over 17, them 17 here are going to cancel, Marika. So in reality, this is working out to be the root of 16 over 18. And the root of 16 over 18 is add up all of the side here. Now we're going to draw for calculator because we're not stressed ourselves, so, right? We don't want to stress ourselves, so not yet. Plus 1 over 588. Whoa, that's what we really get. 9425 over 9996. Can you remind me of that number when we go to the whiteboard? 9425 9425 over what? 9 over 9996. Right, Marika? Right? Can you hear me, Marika? Marika, can you hear me? Can you hear me?
So yes.
All right, now look at this now. Remember that the square root of 16 is what? What is the square root of 16? Square root of 16? Square root of 16 is 4. So that's 4 over the root of 18. We can break up the root of 18 as the root of 9. Good. Root of 9 times the root of 2. Right? Yeah. So now this is now 9, 4, 2, 5 over 9, 9, 9, 6. Now the root of 9 is 3, Marika. So this is 4 over 3 times the root of 2 is equal to 9425 over 9996. So all we have to do is make root 2 the subject from here. It's a lot of work because we have to cross multiply with the 4, then multiply across the 3, then flip it. In other words, we can say 1 over root 2 is equal to cross multiply the 3, divide down the 4. We're saying this is 3 times 9425 over 4 times 9996. It's a lot of work, but yeah, we're good. So let's do it in the calculator here. I'm just gonna multiply this answer now. We're gonna multiply it by 3 over 4, because basically that's what we're doing. 3 over 4. Let me just write it out. What was that again? Dum dum dum. 3 times 9, 4, 2, 5. 3 times 9, 4, 2, 5. 3 times 9, 4, 2, 5. And that's being divided by 4 times 9996. Ooh. That's off. What is this? Okay, I guess we're fine. This is what we get, Marika. 9425 over 13328. So 1 over root 2, we end up getting now, Marika. 1 over root 2 is that answer right there, which was, looking back at the calculator, you won't be able to see it. I'm just displaying it right here. 9425 25 over 13328. So now Marika, to get the answer, we have to flip it. And so root 2 is ending up equal to, when you flip it, it's 13328 over 9425. Now remember, we're required to prove something. So you can't just stop this up. What you have to do is flip it in a calculator. 1 divide by the answer, flip it. Oh shoot, so the calculator won't be able to flip it for us. Because this is a root to 1.41. Can't the calculator simplify it for us? Let's try again. We're gonna have to put this in a calculator. 13328 9425. Please simplify it for us, calculator. We can't. 13328 over 9425. Simplify, calculator. That's crazy.
Sir, press the SD.
It wasn't. It won't give us. It won't give us. It won't give us. So what we're gonna do is we're gonna write that it's the answer. Oh no, this is what it would be. This is our 1,6. Just to verify it, I'm gonna show you that it is indeed true. 1,635 over 1,156. 1,635 over 1,156. No, it's approximately equal to it. I'm going to show you why. On our calculator, notice this is what it gives us, right? 1.41. You mark that down? 1.41, right? Look at this. If you put in the same thing, 1,635 over 1,156. See it there?
Sir, check out the other calculator and see if they have like a simplify option.
The other one?
Yes.
All right, let me see if this one, because we get the same. Why does this one not do it? I really don't know. All right, as I said, let's try the other calculator. 13328 over 9 something. What was that again? This was 9425. 9425. 9425. What's going on? The calculator freeze. Okay. It's not giving me either. It's pretty much saying it can't be simplified then.
Oh, check the setup. Is there no simplify option?
No, I'm seeing something now. Looking at this, this is not exactly the same answer. All right. Oh, there it is, approximately. It's approximately, meaning we're not going to get the exact same thing, but yes, they're approximately equal to each other. Because see there, this is approximately this. All right. This is approximately this. So fine. All right, so this is fine. Oh, good. That's approximately it. So that's what we would do to do this. It's a lot of work because when I look at it, we had to put 1 over 17, we had to get 16 over 17, we had to cancel them there. 16 over 18, and we had to square root this to get 4 over 3 root 2. We have to cross multiply 3 divided by 4. All right, I just want to check back this fraction to make sure this fraction correct. Check this fraction for me and see if you get this. 1 minus 1 over 17 plus 1 over 588. Tell me if you get this fraction. Maybe I made a mistake with the fraction.
Which one, sir?
This one, check this fraction. Add this up and tell me if you get the same as this.
1 minus 1 over 17 plus 1 over,
1 over 588, yeah.
9425, 9 over 9996.
That's what you got? Exactly. Then we're right then. So good. It is an approximation. So good, Marika. So good. So that finished question 4.